Here's part 2 of our trace evidence unit that we're doing on fibers. So we've looked at hairs. The next step is the fibers. Fibers are divided out into two different categories. There are natural fibers, which include things like cotton, which is a plant fiber, wool, which comes from sheep. And since it does come from a living organism, it's actually the hair of a sheep. You are going to see cuticle scales on it. We'll look at that in just a second. Linen, which is woven out of flax fibers. Silk, one of my personal favorites because silk comes from the silkworms. Basically, they have glands in their abdomen that produce this liquid that when the liquid is excreted, the liquid turns into solid, and then it's harvested. I mean, that's not what the silkworms intended for, but it ends up being harvested by humans and turned into thread, which then can be woven into clothing. So basically, if you have a silk tie or a silk scarf or a silk pillowcase or whatever, you are, and it's real silk, you are sleeping on stuff that came out of a worm's butt or wearing it around your neck. So there you go. Hemp then is another type of natural plant fiber. Cashmere comes from a goat, so it is goat hair. That means again that it would have cuticle scales on it. Other types of natural fibers are mohair, also from a goat, and camel hair. Don't ask me why anyone want to wear camel hair, but there you go. And then synthetic fibers are made in factories in a very similar way as to how silk is produced. There are large vats of liquid that's at a very high temperature, and as the liquid is extruded, in other words, it's pulled out through or pushed out through a very narrow opening, it cools and dries very quickly into these fibers. Rayon is an example, polyester, our friend. Any of your technical fibers, if you have shirts made out of technical fabric. Nylon, I know ladies aren't wearing actual nylon so much anymore. Acetate, spandex, Spanx, all of that is synthetic fibers. Now, as far as identifying them from a forensic science standpoint, there are a couple different ways that you can go about doing it. One is microscopic examination, and that's what we're going to take a look at today. Burn testing is another way that you can identify fibers. When you burn different types of fibers, they give off different smells, for one, and someone who is well trained in identifying fibers can identify the different fibers by their smell. That's not a real objective way of doing it. It's very subjective, but if someone is very experienced, they're actually quite accurate in terms of identifying the different types of fibers. The other thing with burn testing is that different fibers will burn differently. They'll have a different color flame. Some fibers will actually flame as they burn. Some fibers really just melt. So if, again, that's a very subjective thing if you're observing this, but someone who's experienced can get very good at it. Now you can use mass spectrometry to identify different fibers and what they're made out of. So there's more objective ways of determining it. And then chemical testing too. If you expose different fibers to acids or other types of chemicals, they will react in different ways, and you can identify them that way. But we're going to focus on microscopic testing. So I'm not going to look at all of these different fibers that we've mentioned, but a few of them. So a few natural fibers. Cotton, the thing to notice about cotton is this big twist in the fibers. And it is a big twist. Look at this one in the background here. And I say that it's a big twist because we're going to look at linen in just a second, which does also have a twist, but it's not quite as tight as this. So cotton's going to have lots of really tight twists in them. It almost looks like a DNA molecule, but it's a much larger piece of material than DNA would be. Wool, again, it's hair from an animal, hair from a sheep, so you are going to see those cuticle scales on it. That's a very easy way to identify wool. Here's the linen, and if you notice right here, there's a good, this line right here is not just a line in the fiber, that's an actual twist in the fiber. And you can see a twist right here in this fiber, and this fiber is twisted as well. But if you notice, and here's a twist in the fiber, the twists are not as tight as in cotton, and they are not as frequently occurring as the twists in cotton. So keep that in mind as you're looking, and feel free to flip back and forth or go back and forth in the video to look at the two different microscopic views. This is silk. Silk, because it's coming out of an organism. It's not hair from an organism, but it comes out as a liquid and then dries. It's not going to have any real clear markings on it, no cuticle scales, no twists. So it's fairly smooth, but if you notice, there are little irregularities, which you would expect when you have a liquid that is solidifying very quickly, that as it comes in contact with the atmosphere. So it's smoother than the other types of fibers, but it does have little bits and pieces here and there of irregularities. So that is what silk looks like. So now let's take a look at some manufactured or synthetic fibers. Here's polyester. Now, it's kind of hard to see on this version. Right here is a good place to look at it. Polyester, all of the synthetic fibers are going to be very smooth because they've been extruded by a machine. But with polyester, you end up with little dots in the fibers. And as we look at more polyester fibers and the activity that will follow this, you'll see that. It's smooth, but it has dots. It's not irregularities like what we saw in the silk, where you've got little bumps and little add-ons. It's actually in the fiber where you're seeing these dots. It's almost like color molecules in a hair piece. Nylon is also smooth, but it has these lines that go parallel down the middle of them. And the reason why these lines are in there, you can kind of see right here, if you look at the end of a nylon fiber, it's almost a triangle shape. So these lines that you're seeing are the places where the fiber changes direction or changes angles. So this part of the nylon is the upright part of the triangle, and this part of the nylon is the angled out to the side type of an angle. And when we meet virtually, I'll show you a better example of that hopefully will help you to picture it a little bit better. Here's acrylic. Acrylic almost looks like a combination of both nylon and polyester. It's got the speckles that polyester does, and it's got this line down the middle of it. And this is a cross section looking at acrylic from the end. So the line that you're seeing down the middle of this acrylic fiber is this groove in the fiber that you see when you look at it from the end. So it's speckles and a line, whereas nylon just has the lines and polyester just has the speckles. So there you go. That's a real quick overview of the different types of fibers, and we'll be talking more about that later this week and working on an activity very similar to what you did for the hair. So I hope that helps. Bye.